Welcome back. Today we are going to cover 2 lessons in one. We're going to save some time. It's going to be awesome. So the first lesson is just talking about conducting experiments to gather data. Basically what this means is you can do experiments to find things out. An example would be taking a dice and rolling it, and you could calculate how many times you rolled the number 6, for instance. Voila! You could also calculate the amount of Oreos that I eat on a daily basis. Whatever it is that you're calculating, it is highly recommended that you add everything together using a tally system. So basically, you're just going to put ticks down, and whenever you get to your 5th sample, so let's say you rolled a dice and you rolled a 3 5 times, well, when you put your 5th tick down, you just make a horizontal line that goes across the vertical lines, which stands for 5. That's literally Unit 7, Lesson 2 summed up. You can do experiments and you use a tally system to count your findings. Whoa! I really don't feel like wasting more of your time than I need to. So let's just end it there. So now we're going to talk about interpreting graphs. So you can actually use the tally system that we just talked about to create graphs. We're not going to create graphs this lesson, but we're going to talk about 2 things: graphs with discrete data and graphs with continuous data. Thumbs up. Basically, there's different types of graphs, and the ones that we're going to talk about today use the 2 different types of data to determine whether a graph has a series of points on it or a graph that has a series of points that are connected. So one graph could have a series of points and you don't connect the dots, and the other one, you connect the dots. When you don't connect the dots, that is called discrete. All right, so you have a discrete graph, which means that you have dots that are not connected. The reason that the dots are not connected is because the information between those dots cannot be measured. An example of this would be if you're selling something like Xboxes. Okay, so let's say we have a store and they're selling Xbox. Let's say you have a store and you're selling Xboxes. Now, you can't sell 1.5 Xboxes or 10.5 Xboxes in a day. You can sell 10 Xboxes or you could sell 11 Xboxes. So let's say you had a graph and you were charting every day on how many Xboxes you were selling. So maybe on day 1 you sold 10, on day 2 you sold 20, on day 3 you sold 15, whatever. You can't sell 15.5 Xboxes. So if you were charting this data, the information between the points isn't valuable. So usually graphs are discrete, the points aren't connected if you're selling something or it's an item that you can't break down or break apart. So like a CD, a DVD, cell phones, cars. These are things that you just can only buy and sell as one item. You can't sell 1.5 rings. That would be kind of physically impossible, but it'd be really weird if you bought 1.5 rings, right? So hopefully you understand that. Okay, so that's the one side of our graphs are a series of points or discrete data, and the other side we call it continuous or a line graph, okay? So generally we call this a line graph because lines connect the points. Why would we connect the points? It's because the information in between each point is
valuable, important, necessary.
An example would be, well, as you can probably tell throughout the course of these YouTube videos, I've been gaining a little bit of weight. I'm sitting at home, I'm not playing as much sports. Well, let's say I was 180 pounds and I went to 200 pounds. I'm actually like 194 pounds, which is heavier than I've been in a while. Anyways, you just can't go from 180 pounds to 194 pounds or whatever the heck I am overnight. You slowly gain and lose weight. On day 1, I charted myself at 180 pounds, and then a week later, I charted myself at being 187 pounds. Well, obviously, if I had day 1 and day 7, the data in between those 2 points is actually important. So that means that I didn't just gain 7 pounds instantly. Another example would be if you're measuring temperature. Well, if you're going to boil some water, the temperature doesn't go from 0 to 400 degrees like that. It takes time. So the time from 0 to 400 is important. Even if you had the best stove or a blowtorch or something, it would still steadily increase the temperature of that water. So let's say you were measuring the temperature of this every 1 minute, and you just check the temperature every minute of the water. Well, you start at 0 and it just slowly goes up, and you just plot your point every minute. Well, the information between those points is important because obviously the temperature is getting warmer steadily, but who wants to write down like 300 points?
I do.
No, you don't. Nobody wants to do that. So basically, you connect the points, and it's called a continuous graph or a line graph because the information is important. So if you're calculating things like temperature, weight, or height, things like that that grow, things that you can measure in between, because obviously you can be, if you're 180 pounds, you could be 180.1 pounds, or temperature can be 27.1, 27.2, blah, 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 blah. So the information between each number is important. So it's really important to understand a discrete and a line graph and the differences between the two. I hope that I have explained myself really well. If not, just go back and rewatch it or comment down below and let me know if you guys are getting it. I have really enjoyed talking with some of you guys, and I appreciate all the comments and likes and all that stuff. It's been great to have some feedback from everybody. So keep me posted on how you guys are doing, and let me know if you need anything else. Anyways, hope you guys have an awesome day today. Have a good one.